Hello everybody, I will start my today another coding practice. So in this video, I will start this question. Minimum area rectangle. So in this question, I'm giving an array point in the xy plane points, where point is x coordinate and y coordinate. Yep. Returns the minimum area of a rectangle formed from this point with size parallel to the x and y axis. If there is not any such rectangle, return 0. I see. So I'm given the list of a point, and actually um this is not always 4 elements. There may be 5 or 6 or maybe 3, only 3 points in the list. And anyway, I will return area of a rectangle from this point. So my first task is to find 4 points which forms a rectangle. Then I will find the biggest one. Then I will return the area of that biggest rectangle. Okay. So yeah, as I said, the point may not be 4. It can be 0, 1, 2, or 3. In that case, I can return 0. And the other case I'd like to think is, yeah, I think I've collected enough information to solve this question. So let me start thinking of the algorithm. So obviously, the brute force approach for this question is pick every 4 combination of the points. Pick every combination of 4 points. Then I will check if it is rectangle or not. Then if it is rectangle, I will keep track of the area. Then from those areas of valid rectangles, I will return the largest one. That's the brute force approach for this question. But what I may think of the more better approach. So what I can say from this rectangle is, if I choose the left bottom point and right top point, then other 2 points are determined automatically and deterministically. So yeah, with that idea, I have to check only 2 combination of 2 points. So it should take only n squared time. Yeah. And for this question, the point of length is up to 500, which is the constraint isn't so strict. I think n squared solution would work. Okay, so let me get started with this. So my approach is quicker. I will outline it. So I will pick 2 points for each. Yeah, it should be like this. And as I said, the time complexity should be O of n squared, and the space complexity should be only O of n. I need this O of n for the set of points. I mean hash set. And with that set in the line 5 to check the valid rectangular node, I have to see all the possible points from that to find 2 remaining points. It should take O of n, but I'd like to avoid it, so I would put all the points in the set, then I will check it. Okay. So the space complexity should be O of n for that set. Oh, one thing I may need to confirm is if there are duplicate points. In that case, in line 5, I have to take care, or I should say in line 3, I have to take care that I don't choose the same duplicated point. And from the constraint, I can confirm that they are unique. So I actually don't have to take care of it. Okay, so that being said, let me get started with implementation. So now I put all the points in the point set. I converted all the points into tuple because in Python set, mutable object cannot be the element of the set. So tuple is immutable, so I converted into the tuple. Then, okay. For each ij point, for each combination of 2 points, I get this. So that being said, the other 2 points should be x1, y2 and x2, y1. So I will check if both of them, I mean each of them is in the point set. And after that, now it's confirmed that x1, y2 and x2, y2 is in the, I mean, same, sorry, they exist in the point set. So I can form the rectangle. However, one thing I have to take care is if the point is like 1, 2, and 1, 3, this means that x-axis is the same and y-axis is different. So it's like this. So even though it's possible that I form another rectangle, if I can, I mean, it may be possible to form a rectangle with those 2 points by looking for another P3, P4, but P1, P2 is not the, I mean, diagonal point. So in this case, if the rectangle really exists in this way, I can find it with P1, P3 pair, P1, P3 combination. And that being said, if I take P1, P2 as a diagonal, another point should be, one of them should be P1, the other is P2, and it cannot be. So basically, I have to skip those cases. Like this. Okay. Now I can form the rectangle. The area should be like this. So I will update the max area with this. Okay. So if there isn't any such rectangle, I should return 0. So this default value, max area is 0, works completely fine. And I will return the max area. Okay. Let me walk through my code with more example. So I think this example 1 is a good case to test with. So firstly, I have this point. The point set should be, yeah, like this. Then in line 22, length of the point is 5. So in line 23, I should be 0 to 4. And for each, I will take a look at each j. So how many? Yeah, 5 times 4 divided by 2 is 10 combinations in total. It should be too many. So let me quickly take a look at the only case where the rectangle is formed. So, okay, sorry. Let me take a look at the cases where rectangles are formed, and also one more case where rectangle is not formed. So rectangle cannot be formed, say I pick 1, 1, and 2, 2. So in this case, in line 29, x1 is 1, y1 is 1, x2 is 2, y2 is 2. And then line 32, this is not correct. I go to line 34, and x1, y2, which is 1, 2, is not in the point set. So I will continue. So this 1, 1, 2, 2 case is skipped as expected. Okay. Then I will think of the case when a rectangle is formed, which should be when I take 1, 1, and 3, 3, and also 1, 3, and 3, 1. So in the former case, this in line 32, x1, 1, y1, 1, and x2, 3, y2, 3. So in line 35, this is not true. I go to line 37. And now x1, y2 is 1, 3, which is in the list. Yes, no set. Yeah. And x2, y2, x2, y1, which is 1, 3. Wait. 1, 3, 1, 1, 3, 3. It should be 1, 3, and 3, 1. Ah, yeah, right. 1, 3. Should be the other 2 points should be 1. Oh, yeah. 1, 3, and 3, 1. Right. And 1, 3, and 3, 1. Each of them are in the point set. I will keep going to line 42. Then I calculate the area by 2 times 2 is 4. So now max area is updated with 4. Yep. Okay, another case, 1, 3, and 3, 1 case. x1, y1 is 1, 3, x2, y2 is 3, 1. So line 35 is not true. And line 37, x1, y2, which is 1, 1, is in the list. Yes. And then line 39, 3, 3 is in the set. True. So I go to line 42, then area should be again 2 by 2 is 4. So max area is now 4 again. So in line 45, I return max area 4. Okay. So now I'm quite confident in my code, so I will execute. Oh. So in case 2, something is wrong. Wait. I should return minimum area. Okay. So let me change this mini area default to infinity. Then I update mini area with each area. Then if mini area is still infinity, it means that I couldn't find any rectangle. So I will return 0. However, if it's not infinity, it means that I found a rectangle, valid rectangle. So I return my mini area. Yep, so this is it. Okay, I will choose my code again. Good, I will submit it. Okay, so now it's accepted. So let me finish my today's coding practice. Yeah, after wrapping up this question. So this question is minimum area rectangle. And my task was to find, given the list of points, I will think of every valid rectangle from those points. And I will return the mini area of those valid rectangles found. So as a solution, my idea is that I pick 2 points as diagonal points. Then I decide 2 other points, from those 2 points. Pick up points. And if 2 other points found, I can say I can find a rectangle. So I calculate the area of that rectangle. And finally, I return mini of all the valid rectangle areas. That's it. Good. Okay. The solution is, each of the solutions should take n squared time. So I think this is the best achievable time complexity optimization. So I will finish my today's coding practice with this. Thank you so much. Bye.